Hello my dear class 10 students, a very warm welcome to you all. How are you? I hope you're doing amazing. This is your Ekta ma'am here, your chemistry faculty. In this video, we will be doing a 10-minute summary of the chapter Acid, Bases and Salt. So, what are acids? Acids are sour in taste. They turn blue litmus red. They give hydrogen ion, H positive ions when dissolved in aqueous solution. They conduct electricity in aqueous solution. Due to these hydrogen ions, they have a pH less than 7. Now, what are the two types of acids? We have strong acids and we have weak acids. Strong acids are those acids which dissociate completely in aqueous solution. As soon as you put them in solution, they will dissociate as their respective ions. HCl will dissociate as H positive and Cl negative. H2SO4 will dissociate as H positive and SO4 2 negative. Now, what about weak acids? Weak acids are those acids which dissociate partially or incompletely in aqueous solution. Okay. For example, acetic acid, carbonic acid, these are weak acid. They do not dissociate completely in aqueous solution. Okay. Okay. What about bases? Bases are bitter in taste. They turn red litmus blue. And what kind of ions are given by bases? Yes, they give OH negative, that is hydroxide ion. Now, water soluble bases are called alkalis. We have bases that may or may not be soluble in water, but the water soluble bases are called alkalis. Okay. Now, what about pH? Bases have a pH greater than 7. Now, similar to those, we have two type of bases, strong bases and weak bases. Strong bases are those bases which dissociate completely in aqueous solution as OH negative ions and the respective cations. Okay. In aqueous solution, bases give OH negative, hydroxide ions. Okay. What about weak bases? Again, weak bases are those bases which dissociate partially or incompletely in aqueous solution. Moving on. Alkalis. Yes, what are alkalis? We have bases, okay? They can be water soluble or they cannot be water soluble. They can be water soluble or they can be water insoluble, okay? Alkalis are those bases which are water soluble, that dissolve in water. For example, sodium hydroxide, potassium hydroxide, these all are alkalis. Some properties of alkalis, they are soft, have low density, they are very reactive, they have low melting and boiling point, and you store them in mineral oil solutions. Okay. Now, what about the chemical properties of acids? Acids show some chemical properties, some chemical reactions that are characteristic for acids. What are those reactions? Okay, they react with metal. Acids react with metal and evolve hydrogen gas. Okay. Now, acids also react with metal carbonates, metal hydrogen carbonate, and they evolve carbon dioxide gas. Okay. Next one. Acids react with metal oxides. Now, what is the nature of metal oxides, my dear kids? Yes, metal oxides are basic in nature. And whenever an acid and base react, we get salt plus water. Okay. So, whenever an acid and metal oxide will react, we will get a salt and water. Okay. Moving on to the chemical properties of bases. What are the chemical reactions shown by bases? So, firstly, bases react with metals. Oh, acids also react with metals. And what gas did they evolve? Hydrogen gas. Okay. Similarly, bases also react with metal and they evolve hydrogen gas. Okay. I have taken an example of zinc and aluminum. They are both amphoteric in nature. What do you mean by amphoteric, ma'am? Amphoteric mean that they can act as acid and base. Okay. So that means they can react with both acids and base. If they are reacting with acid, they are behaving as base. If they are reacting with a base, they are behaving as an acid. Okay. These are two important reactions from the acid bases. Okay. Now, the second reaction is reaction with non-metallic oxides. What is the nature of non-metallic oxides? Yes, non-metallic oxides are acidic in nature, and when base and acid reacts, we get salt and water. We get salt and water. Moving on to the next reaction, reaction with acid. My dear kids, when acids and bases react, we get salt. That is the third part of this chapter, acid, bases and salts. Moving on. The pH scale. What is the pH scale? It is a scale showing the acidity. It is showing the hydrogen ion concentration. Okay. What is pH? Negative logarithm of H positive. You do not need the definition for your 10th class board. Trust me. Okay. What is pH exactly? It is a scale from 0 to 14 showing the hydrogen ion concentration. Okay, more the hydrogen ion concentration, lower will be the pH value. Less the hydrogen ion concentration, more will be the pH value. So we'll start from 0 to 14, from highly acidic to highly alkaline, and in between we have neutral. So for example, battery, the acid that is in battery is very acidic, highly acidic, and sodium hydroxide, here we have sodium hydroxide, it will be highly alkaline. Okay, my dear kids, moving on. Indicators. What are indicators? So indicators are those species or those compounds that are used to determine whether we have an acid or a base. Okay, we can determine what kind of substance we are dealing with, an acid or a base. Okay, so what are the commonly used indicators in this chapter? We have litmus paper. Okay, what do acids do? Acids turn red, blue litmus paper red. What about bases? Bases turn red litmus blue. Phenolphthalein is also an indicator. Okay, what does phenolphthalein do? When you put phenolphthalein in an acidic solution, it will remain colorless, but if you put phenolphthalein in a basic solution, it will become pink color. Okay, what about methyl orange? Methyl orange, in case of acidic solution, it is red in color, and with basic solution it will turn yellow in color. Okay, so that's how you can determine whether the compound or substance you're given is an acid or a base, my dear kids. Okay, now what about olfactory indicators? Olfactory means they are smell based. By their smell you can figure out whether you are given an acid or a base. Okay, here we have onion and vanilla extract. Both of these, if they are treated with an acid, they will retain their odor. Okay, they will not lose their odor. Okay, but if they are put in a basic solution, they will lose their odor. Okay, these are the indicators. Moving on to salts, my dear kids. Okay, what are salts? They are a product of neutralization between an acid and a base. Now there are three types of salts, right? We have neutral salt, acidic salt, and basic salt, depending on the type of acids and bases that we are using. If we have a strong acid and a strong base, what kind of salt we get? We get a neutral salt. If we have a strong base and a weak acid, we get a basic salt. If we have a strong acid and weak base, we get an acidic salt. Okay, comment down below the example of each of these salt. Okay, now what are the properties of salt? Properties, salt can be acidic, basic, or neutral. Okay, they conduct electricity. Salt conduct electricity in their molten state or aqueous solution. When you dissolve them in water or you make a molten solution of them. Okay, in their solid state they won't conduct electricity. Salt is pretty solid, right? You have seen the crystals of salt that we eat every day. Okay, moving on. They have high melting and boiling point because they are ionic compounds. Again, my dear kids, ionic compounds and covalent compounds we will discuss in the carbonated compound chapter. Moving on. Salts are insoluble. Again, they are ionic compound, so they will be insoluble in organic solvents. What are organic solvents? Which do not have any charge. Okay, non-polar. Now, what are the different type of salts that we are dealing in this chapter? The first one is common salt. What is common salt? Sodium chloride, the one that we are eating every day. Okay. NaCl, how do we synthesize it? One of the simplest method we have, we combine strong acid HCl with an NaOH, a strong base, we get NaCl, right? But no, my dear kids, that's not how we synthesize it. We synthesize it by C. You have C, right? It has large concentration of salt. So we seawater, right? So we take seawater, we evaporize all the water, and what we are left with? We are left with common salt that is later on purified and used for eating purposes. Okay, because if you are adding acid to anything, obviously that is not edible, my dear kids. Now, where is it used? It is used as a food preservative and also as a raw material for sodium carbonate, sodium hydrogen carbonate. Okay, moving on. Next one is caustic soda. What is caustic soda? Caustic soda is sodium hydroxide. What is caustic soda? It is sodium hydroxide. Okay, how do you synthesize sodium hydroxide? A process called chlor-alkali process. What is chlor-alkali process? When you take a brine, what is brine? Brine is an aqueous solution, concentrated aqueous solution of sodium chloride. Concentrated aqueous solution of sodium chloride, and when you pass electricity through it, what do you get? You get sodium hydroxide. You get sodium hydroxide, chlorine, and H2. Now, what are you getting at anode, at cathode, and you know. So at anode we are getting chlorine, at anode we are getting chlorine gas, at cathode we are getting hydrogen, and also sodium hydroxide or caustic soda solution is also there at the cathode, my dear kids. So remember, this question might come from this part. Okay, now where we use it? We use it for soaps, detergents, and for degreasing metals. Next salt is bleaching powder. Where do you use bleaching powder? To bleach our hair, right? Okay, to bleach our clothes also we use it, and sometimes as a disinfectant, right? So what is bleaching powder? Bleaching powder is calcium oxychloride, CaOCl2. That is bleaching powder. The chemical name is calcium oxychloride. How do you prepare it? We prepare it by this process. When we have a slaked lime, right, and we pass chlorine gas through it. If we have slaked lime and if we pass chlorine gas through it, what do we get? We get calcium oxychloride. Okay, my dear kids, what is the bleaching agent in case of bleaching powder? The bleaching agent is chlorine gas. That is the bleaching agent. This calcium oxychloride serves as a purpose to store this chlorine gas. It is not the bleaching agent. The bleaching agent is chlorine gas, Cl2. Okay, now sometimes to save some byproduct, to save degradation of our environment, the chlorine gas that was evolved during the chlor-alkali process, that is used to synthesize bleaching powder. Now what are the uses? We used is to make drinking water germ free, as a disinfectant, and also as an oxidizing agent in many industries, my dear kids. Okay, now this is how you get the firstly how you get the bleaching powder, which is the bleaching, you get it by passing chlorine gas from calcium hydroxide or your slaked lime. That's how you get bleaching powder. Now how do you get your bleaching agent? Chlorine gas by adding dilute hydrochloric acid or any dilute acid to this bleaching powder. That's how you get the bleaching agent, my dear kids. Moving on to the next salt, baking soda. What is baking soda? Where do you use baking soda? We use it to make pakoda, right? We use it to make for baking purposes, right? No, we use baking powder for baking purposes. Okay, it is sodium hydrogen carbonate. The chemical formula is NaHCO3. You synthesize it by how? This process is called Solvay process. Okay, this process is called Solvay process. This one and one more reaction that is in the next slide. Okay, so sodium chloride, we take a brine solution and we put ammonia and we pass carbon dioxide gas through it, and what we get, my dear kids? We get sodium hydrogen carbonate. That is our baking soda. It is used for making crispy pakoras and also as soda acid fire extinguisher. One more thing you should remember. What about baking powder? So baking powder is a mixture of baking soda and an edible acid. Baking powder is a mixture of baking soda and an edible acid, which is normally we use tartaric acid. Okay, moving on, washing soda. What is washing soda? So I have done one part. I have synthesized sodium hydrogen carbonate. That is baking soda. Now how I synthesize washing soda? That is very simple. If I just add 10 water of crystallization. So firstly I take firstly I'll take baking soda and then I decompose it. I heat that baking soda, and that's how I get Na2CO3, which is sodium carbonate. That's how I get sodium carbonate. So if you have NaHCO3 and if you heat it, we get sodium carbonate, right? Sodium carbonate, if we heat it, and this sodium carbonate is added, like if we have the sodium carbonate and if we add 10 water crystallization to it, and that's how we get washing soda, my dear kids. Now where is it used? It is used for removing permanent hardness of water and as a cleansing agent for domestic purposes. Moving on, plaster of Paris. What is plaster of Paris? When along your in your life you may have fractured some of your bones, you may have fallen down and you have hurt yourself, then doctor put a cast on your hand or arm wherever you have broken your anything. Okay, so what is that? That is plaster of Paris. How do you synthesize plaster of Paris? Firstly, what is plaster of Paris? It is calcium sulfate dot half H2O. That is plaster of Paris. Okay, calcium sulfate hemihydrate. How you synthesize it? You take gypsum, which is calcium sulfate dot 2H2O. Okay, calcium sulfate dihydrate. Okay, now if we heat that at around 100 degrees Celsius, at around 100 degrees Celsius or 373 Kelvin, what will happen? It will lose its 1.5 water of crystallization, and we get plaster of Paris. Where is it used? To support the fractured bonds and a material for smoothing surfaces or making toys. That's where plaster of Paris is used. Moving on. Yes, we are done, my dear kids. The chapter is done. All the important things, that important summary of this chapter are done. All the best for your board exams. Take care. Bye.